In the soil, we have our minerals and organic matter. Those are the sources of those elements that we need. But the elements are part of molecules, either in the organic matter like lignin and starch, cellulose, or actin and myosin like muscle molecules. Or in the minerals, we have also complex molecules, and they even form linkages. So it's not just like we can go up and suck a couple elements off, right? So plants need those elements out of the soil, right? But they don't have teeth. So they can't just grow up to a piece of straw and start chomping away and break that down and slurp it in. No, they can only take in, absorb from the soil water, right? So either the element itself or a simple molecule containing that element. See, roots have these tiny little either channels or special transport proteins that make a space specifically for a certain type of molecule to enter. So in the case of nitrogen, plants only absorb either ammonium, NH4+, or nitrate, NO3-. We'll talk about the minus plus later. There is an exception of a few small types of amino acids, but it's not going to just like mosey up to a big old complex DNA molecule and be like slurp slurp. No, it has specific things it can do, only those molecules, certain molecules that can enter. So the question is, how does the soil provide those molecules and how does the plant get to them? So all those minerals in the soil and all that complex organic matter needs to get broken down somehow, right? Now, the minerals, I have to talk about minerals, they're firstly broken down by weathering, right? Freezing, thawing, water, sometimes a worm will pass by or some insect and chew on that. There are also some chemical processes that occur on the surface of the mineral and start to break that down like acids, And when it gets down to small enough particles, earthworms actually eat the minerals in the soil, and as they pass through, they have a gizzard. Worms have a gizzard like a chicken, right? It has gravel in it and grinds things. So that happens to the mineral, and then there's acids in its stomach, and that gets working on the mineral, and then it gets out the other end, and it's like really good stuff. You have no idea. That's why they sell worm poop, worm casts. So minerals, that's sort of how they're breaking down. Then you have the organic matter. Organic matter, like I said, can start breaking down by the action of chemical processes like oxidation, where there's that brown stuff on your banana, on your apple. But then you also have a lot of microorganisms and insects that will start breaking these down. And the first thing that they will use is the starches and the sugar. Simple molecules. They're like potato chips and ice cream, for bugs. Easy, simple to eat, and your little sugar high. But then the tougher stuff, lignin, the fats actually are a difficult molecule for the decomposers to break down. There are specific types of microorganisms that work on those, and they take a while longer to get broken down. So I have a picture of a plant root here in the middle of I think it's a clay molecule. And the old frame of that plant root is still stuck in the soil, while all the contents, the really good starch and sugar and all the easy stuff, have been eaten long ago. Now, eventually, there are bits and byproducts of everything that has been broken down that the plant can actually absorb in the forms, those specific molecules on the table. Eventually, the organic matter and the minerals are broken down into small enough particles, those specific molecules that our plant roots can absorb. So you might say, phew, like finally our plant has won its struggle for survival and it can eat up and grow. But alas, there is some unfortunate chemistry. The chemical breakdown of minerals and organic matter actually results in positive and negative charges across their surfaces. You see, every atom of every element has electrons. These are these negatively charged particles around it, around the nucleus. Some have more, some have less. That's the number on the table of each element. They also have the same number of protons, normally positively charged particles in the middle, that nucleus. The electrons on the outside sometimes get stolen. The thief atom gets a net negative charge because he is an extra minus, and the victim ends up with positive charge. So, like, I lost my electron, So try to keep this simple. The loss or gain of electrons on the surface of soil minerals or organic matter creates a charge. So either a positive charge or a negative, a magnetism. I don't have the time to explain all of this. Just so you know, most of our soils will have a net negative charge. That means there will be places on the surface of that soil that have a positive charge, but mostly there are places with negative charges, the thieves. So, we have our nutrient molecule that could be used by the plant. It gets released from a mineral structure or some organic matter and it goes happily floating along. But it has a charge on it, and so it gets stuck to the surface of some other mineral or organic matter. Magnetism, right? But if perhaps some other molecule floats up and nudges them off, like, fighting for the same spot, they might be free to be drawn to the plant again. I know this might seem unnecessarily complicated. I mean, why do we have to explain how the molecule gets stuck to the surface of the soil? But think about what happens when you put a ton of ammonium nitrate on your field, right? It quickly breaks apart in the presence of water into ammonium and nitrate. But then ammonium, being quite positive, can get stuck on our negatively charged soil particle. And nitrate, negative poor little depressive guy, goes floating along either to our plant root or down into the earth if there's enough rain to percolate into the groundwater, where it is lost forever and ever. In our last segment of How Soil Works, I will tell you about nutrient movement to plant roots and tie up all of these horribly complex chemical processes into one nice neat bow, or at least attempt, before we move on to managing soil fertility.